Okay. Hi everyone. Can you hear me? All right. Thanks, Juan. Welcome to week 11 prac. How did you go with your quiz? Yeah, Ashish says good. Then it must be easy. Any concerns? No? All right. For this week, there are two parts in that notebook. The first part is we go through the quiz questions. And the second part is we will discuss exponential distribution, which is a probability distribution. Okay, you may have come across that before, but let's revise that. Okay. Let me share my screen. Okay, the first part is in section 1, we'll go through the quiz 2 questions. And section 2, we'll discuss about exponential distribution and explore some of the properties. And you are going to derive some of those properties using calculus. All right. Okay, the quiz questions are here. You guys see the quiz? Can you see the quiz questions? No, yes? Okay, I'm trying to find the quiz. Okay, I'm assuming that you have the questions with you. It's available on Blackboard. Do you guys have it with you? Can you access the quiz questions? Let me show you where it is. Okay, so I will not show the questions because I'm only showing how the solutions are derived. Okay, please have a look at the quiz questions. The first question is evaluate each of the following expressions, justifying your answer. Okay, so question 1, the first part is limit x tends to infinity e power minus 1 over x squared. How would you evaluate this? Anyone? E to the power 0, why? Ashish. Okay, the first thing you should notice is let's say what is limit x tends to infinity of minus 1 over x squared. This should be equal to 0. Okay, then that means limit x tends to infinity of e to the power that is minus 1 over x squared would be e to the power 0, which is 1. Okay, and you also need to say that the exponential function is continuous. Everywhere in this case, possibly at 0. Okay, that's the first part. The second part is find the limit is x tend to 2, x minus 2 over cos pi x plus 1 minus x. Okay, how would you approach this? Yeah, so as x approaches to 2, that's 0 over 0 case. What do you do now? Yeah, what's that process called? Yep, L'Hopital's rule. Okay, so using L'Hopital's rule, you got limit x tends to 2 of x minus 2 cos pi x plus 1 minus x should be equal to limit as x tends to 2 of, you would differentiate this d by dx of your numerator, divide by d by dx of the denominator, which is cos pi x plus 1 minus x, which is equal to limit as x tends to 2 of, what's the derivative of the numerator? 1, okay, derivative of denominator. Derivative of cos x is, what is derivative of cos x? Minus pi sine pi x, okay, minus 1, which is equal to 1 over minus pi, so sine of 2 pi minus 1. What is sine of 2 pi? Zero. Okay. I can see only one person answering, so 0 minus 1, which is minus 1. Okay, that's the second part. Third part. Find the limit of as x tends to 0 of fx, where fx is you have fx defined as x less than minus x if x is negative, and the other way around is minus x power plus 10 fx x power 5 if x is positive. Okay, how do you find limit as x tends to 0 of fx? Yeah, you can say, you can use the squeeze theorem. Okay, in this case, if x is negative, so limit from the left, let's say, if x is negative, you have fx between x minus x. So you could consider this as gx and hx, okay? And then say that limit x tends to 0 of gx equals 0, which is also limit x tends to 0 of hx. Okay, therefore, if x is negative, limit x tends to 0 of fx is 0 by the squeeze theorem. Okay, from the right, if x is positive, you have x between minus x to the power 10 fx x to the power 5 And then again, you can say this is gx plus hx. And therefore, limit as x tends to 0 from the right, gx is equal to what? Zero, yeah, which is also the same as limit x tends to 0 of hx. Okay, therefore, limit x tends to 0 of fx is equal to 0 by the Squeeze theorem. Some people call this sandwich theorem. So in conclusion, therefore, limit x tends to 0 of fx is equal to 0 when for all x not equal to 0. Okay, that's the third part. Fourth part is you are asked to find the sum series n equals 1 e to the power pi n. Okay. How would you approach this question? What sort of method are you gonna? E can be moved out, yes. So what's the purpose? Yep, geometric series. You can consider this as a geometric series where you have n equals 1 e, and then you got 1 over pi n. Okay, does this converge? Okay, so your a is e, r is 1 over pi. Okay, common ratio is less than 1. This is less than 1, yeah. So you can say series converges. What is the convergent value? To what? A over 1 minus r, okay, which is equal to, is it r minus 1 or 1 minus r? I think we discussed this before. A over 1 minus r. A is e, 1 minus 1 over pi, which you can simplify as pi e, pi minus 1. Okay. Fifth one, you are asked to find the limit as x tends to infinity of x minus 2 cos of 2 pi, not 2 pi, pi x. Pi x plus 1 minus x. Okay, how are you going to approach this one? The fifth one, how do you find this limit? Okay, squeeze theorem. Okay, you might want to start with cos of pi x. Okay, what are the bounds? What are these bounds? Okay, someone? That's between -1 and +1. Okay, then you can add +1, -1, +1. Because of pi x. Or +1 minus x. You can straight away add it. +1 minus x. 1. That was +1 minus x, which is minus x, cos pi x. +1 minus x, 2 minus x. Okay, but we want that to be divided by x minus, so divide by x minus 2. So when you flip the inequality using the rules of inequality, that would be x minus 2 divided by 2 minus x, x minus 2 divided by cos pi x, +1 minus x, is then equal to x minus 2 divided by minus x. Okay, again, you can consider this to be your gx, that to be your hx, okay, and that would be limit as x tends to infinity of gx. What is that? How would you find this? Why is it -1? Okay, divide by x both numerator and denominator. So that would be 1 minus 2 by x. Sorry, I forgot to write. As x tends to infinity of 1 minus 2 by x. Minus 1, which is equal to 1 minus 0, 0 minus 1, which is -1. Okay. And then limit x tends to infinity of your hx is equal to limit x tends to infinity. Use the same rule, divide by x, because x is the power of x. X has 1 power 1 is the highest power is 1 in the denominator. So that's 1 minus -1, which is okay. That means therefore limit x tends to infinity of your fx. Call this fx equal to -1 by the squeeze theorem. Okay, are we done with question 1? Okay, let's move on to question 2. Consider this function fx equals 0 e power -1 over x squared. If x equals 0, x not equals 0. Okay, show that f is continuous at any non-zero value of x. How are you going to show that? Did I make a mistake in number 4? She says it should be e divided by pi minus 1. Why is A equals e divided by pi? Do you see any mistake? Maybe you're right. Let me check. Okay, I'll check this. Okay, I'll come back to this. Okay. All right, let's look at 0, x equals, what do we have to do for this question? Show that f is continuous at any non-zero value of x. The exponential function, I have done this before. Okay, let's argue it in this way. Minus 1 over x squared is continuous for all x not equal to 0. And since exponential function is continuous everywhere, fx is continuous except x equals 0. Okay. The second part of the question is calculate f dash x for each x not equal to 0. This is by using the chain rule. You can compute this as minus 2x cubed e to power minus 1 over x squared, okay, minus x squared. Is that clear? All right. The next part is show that fx is continuous at x equals 0. Remember last time we discussed continuous at a point using definition 12 on page 102. There are 3 criteria that you need to check. That is, f at that point is defined, and limit as x tends to a of fx exists. Limit x tends to a of fx equals f of a. Okay, so a in this case is x equals 0. Okay, the first point is true because f of 0 is 0 and x equals 0 is in the domain. Okay, the second part, we got limit x tends to 0, minus 1 over x is negative infinity, and limit of exponential function, exponential of minus y is y tends to minus infinity is 0. Okay, so that limit exists. And then the third point is limit x tends to 0 of fx is 0, which is also f of 0. Therefore, fx is continuous at x equals 0. Okay, is that clear? Okay, next question. Third part is, question 3. Consider the real valued functions fx equals x cubed plus 4x squared minus 20x plus 1. Calculate the first derivative and second derivative of f. Okay, what is the first derivative? Should be easy. What's the first derivative? Yeah, 3x squared plus 12, oh no, 8x minus 20. Is that what I, yeah. Second derivative. Yeah, 6x plus 8. Thanks, Ashish. The first part. Second part is find all of the critical points of f. Determine if they are local maxima or minima. How do you find critical points? Yeah, f dash x equals 0, solve for x. When you solve for x, how do you find that solution? 3x squared plus 8x minus 20 equals 0. How do you find that's the solutions? How many solutions would be there? It's a quadratic equation. You have 2 solutions. How do you find the solution? Yeah. Discriminant is 0. Is positive. Yeah, real solutions exists. What do you do to find the solutions? Yeah, you would use the quadratic formula. Okay, that is, if your equation is ax squared plus bx plus c equals 0, x is minus b plus or minus b squared minus 4ac over 2a, which when applied gave me this solution, 2/3 times minus 2 plus or minus square root of 19. Okay. That's the second part. Oh, we also need to determine if they are local maxima or minima. How do you do that? Which method would you be using to determine for local maxima or minima? yeah, you could use second derivative test. Okay, I've used second derivative test. At x equals like the positive part of the square root, that is 2/3 minus 2 plus square root of 9 is positive. So that's the local minimum. And for the second point, I got minus 17. Is that right? Minus 17.4, which is negative. Let me check. I did this before, so I must have solutions. Second derivative is 6 times x plus 8, which is 17, and minus 17. Yeah. So one is positive, which is local minimum. The other one is local maximum. And number 3 is the third part is how many distinct real valued roots does f have? Prove your answer by making reference to intermediate value theorem and mean value theorem. How would you approach the third part? How many solutions? How many distinct roots for fx? Anyone? Find fx where fx is negative or positive. Yeah, that's a good start. And what's the next point? Okay, let's say at the critical point, x1, which is 2/3 minus times minus 2 minus 19. Sorry, f of x2, that is at this point. I got f of x2 is negative and f of x1 is positive. Okay, the sign changes. Which rule can you apply? What does that mean? Yep, by the intermediate value theorem, there exists at least one root in the interval x1 and x2. Then you can use the mean value theorem because when we took the derivatives, there's no more than one root as f dash x is negative between x1 and x2. Then let's look at some other point. X0 is minus 10 and plus x3 is plus 10. I got again sign changes for f. Then again, by the intermediate value theorem, there exists 2 more roots since f dash is positive outside. Is that the intermediate value? This is mean value theorem. Okay, that's about quiz 2. I've also shared with you about exponential distribution. Okay, the second part, I will briefly discuss this, but then continue this exponential distribution properties next week also. Okay, are you familiar with exponential distribution? What is it used for? No, not yet. Okay, it's a probability. It's used in probability and the statistics often to model. It's a continuous distribution, and it is used to model measurement expected time for an event to occur. Okay, to measure that time. So, for example, in physics, it's often used to measure radioactive decay. Engineering, it's used to measure the time associated with receiving a defective part on an assembly line. In finance, it's used to measure the likelihood of the next default for a portfolio. And also it can be used to measure likelihood of incurring a specific number of defaults within a specified time period. So it has got many applications in real life. Okay, by definition, if a random variable has exponential distribution with parameter lambda, we write it as x is distributed like exponentially. EXP is shorthand notation with parameter lambda. Here lambda is always positive, and it's called the rate parameter. And x takes values in the interval 0 to infinity. And associated with this distribution, or for any continuous distribution, there are two properties that you can define, which one is called the probability density function, or PDF of, and the PDF of an exponential distribution is given by lambda. In its notation is f sub x lambda. Different texts uses different notations, but I'll stick with this. It's lambda e to power minus lambda x when x is bigger than or equal to 0, and 0 otherwise. And the other property is the cumulative distribution function, which is called the CDF of x, which is defined using the capital F. It is the probability that the random variable x is less than or equal to a given value x, which is 1 minus e power minus lambda x. Now, let me explain the relationship between PDF and CDF. All right, let's say in general, okay, not necessarily exponential distribution, for any continuous random variable x, you can take the probability that x lies within an interval a, b, by computing the area under the curve of fx dx, okay, which is integral of your PDF, that is the probability density of x between a and b. So that's in general for any continuous distribution. Continuous means it can take any value between these A and B. Okay, then the CDF, which is called the CDF. This is PDF. Okay, the CDF is defined in general as probability that X is less than or equal to any X for the X is between -infinity to any X, given X value, which is computed using, again, integral of your PDF from -infinity to X. Now, if the PDF is continuous at X, then the relationship between the PDF and CDF, PDF and CDF, cumulative distribution function is, you can get the PDF by differentiating the CDF. Okay, so intuitively, this means the PDF times small value dx is the probability of X falling within the interval X and X plus dx. Okay, so that's the relationship between PDF and CDF. Now coming back to exponential distribution. Okay, that's what I just discussed for in general. Okay, these things are true in general for any continuous random variable. Let's look at question 1. Use integration to compute the CDF of exponential X distributed as exponential with parameter lambda is given in equation 1. How are you going to do that? Can you show this? Remember, the definition of CDF is this part. Can you use this in the exponential case and show that its CDF is 1 minus e power minus lambda x? Yeah, Ashish, you're right. You would integrate it from 0 to x. Would you be using integration by parts here? What's the PDF? Yeah, integration by parts is not required at the moment, but later on you will need it. I can show you. So by definition, this is definition that I discussed previously. This is f of x dt, and then the bounds are from 0 to x. Why? Because x is defined from 0 onwards. Okay, and take the derivative with respect to t here, which is the integration of e power minus delta minus lambda t is minus 1 over lambda e power minus lambda t, and then evaluated this at x and 0, you get this part here. Okay, so that means the CDF is 1 minus e power minus lambda x when x is positive, greater than or equal to 0 and 0 elsewhere. Okay, is that clear? All right. I think we ran out of time, but I have also given other properties, how to compute the other properties in that notebook. Okay, so question 2 is plot the CDF and PDF for a given lambda. You can use Mathematical's plot function. I'll update this on GitHub. And then also the mean and variance of a continuous random variable is defined. The mean is defined as integral of x, fx, and the variance is defined as integral of x squared fx dx minus the mean squared. I'll explain how this is how that is arrived next week. And then could you try question 3 and question 4? Sorry, that should be question 4 for the next week. Okay, you got to show that the mean of the exponential is 1 over lambda and variance is 1 over lambda squared. You might need integration by parts here. Okay. Any questions? I'll stop.